Hello and welcome to Structural Analysis MCAD. This is a brief video to give an overview of how to use the Structural Analysis MCAD for all your simple plane frame analysis. Let's jump into the program. So this program was designed in order to eliminate the need to start your calculations in MathCAD and then have to go to other programs to do the analysis. This way you can do all of your analysis and design in one program. Now, this program, it can be used for any size structures, but we recommend staying within 10 to 20 nodes just for ease of inputting in data. After that, it gets a little more complicated. Now, this sheet is designed is separated into three different sections. The general design input, where we put in a generic type of structure that we're looking to design. We put in member properties and end conditions. Then in section 2, we customize the design for the exact design we're looking for. We put in the correct geometries, we put in the loads, the end conditions, and then once we've customized our analysis, section 3 gives us the results. Here we can look at the axial load, the shear diagram, the moment diagram, the reaction forces, and the nodal deflection for your structure. So let's begin looking at our first structure today. We're going to look at a simple moment frame. So I clicked on the moment frame button. Now I jump down here to the moment frame analysis section. I'll place for simplicity, we're just going to do one bay. We'll keep the bay width at 10 feet, the bay height at 10 feet, and we'll change the Gable height to 15 feet. We'll leave the column supports as pinned. In the next section we have property databases. Here we have supplied a number of different databases like AISC shapes for your convenience, so you don't have to look into all your books to get the areas and the moment of inertia required for this design, for this analysis. Or you can use a standard parametric shape, so you can say what type of shape you want to do, and then you can modify it for your specific needs to create your own shape, and then from there pull off these areas of moment of inertia for the design. So once you get one of these values, then you copy and paste them into the blue vectors, or into the blue inputs. So throughout this sheet, you'll notice green will be for user's notes, so you know what to do and when to do it. Pink are values that can be copied and pasted into our input section, and blue is our input section. Now that we've got our moment frame generally designed, we'll come down to the the custom design inputs. Now we'll copy and paste from the pink vectors and copy and paste them into the blue vectors. And notice the graph below as I do this. It changes from the continuous beam that I had analyzed previously to our moment frame, with the height of 15 and the bay height of 10 and the width of 10, like we mentioned earlier. The reason why we have to copy and paste is that way it gives you the ease of having custom designs, but it also allows you to change the structure. You can come in here and change any location, any point you want, and you're not stuck with one custom design, one preset design. The same goes for the end conditions and loads. You can come in here, let's say we want this to be fixed instead of pinned. So we have one pinned, one fixed. And then the loads, we do the exact same thing. So then we can come into the blue vector and change our loads. So this is for uniform distributed axial loads. If we wanted all the members to have the same axial load, instead of having to type them all in down here, we would come up here and just put in the load we want, which updates this vector, and then we could copy and paste into there. And at this time I'm just going to leave it at 0 though. And then we follow that same process for the different loading conditions. So this is for some reason it's not working. There we go. So this is for a distributed load. We come in here, let's say we wanted, like it shows here, minus 75 pounds per foot on one end and 200 pounds on the other. We'd come into this member 1, and on node 1 we put 75 pounds per foot, and on node 2, 200 pounds per foot. So you just have to keep track of the nodes and members. And then we do the same thing for distributed loads like snow loads or dead loads. Same for point loads. The only difference is here you would specify in this vector here where you want the point load to be located along the length of your member. And last, we take the applied external loads on the nodes. So in the X direction, in the Y direction, and finally the applied moments at the nodes. And then again we have the databases repeated, so that way you can customize each member to be a different shape or size depending on your needs, so you can modify the design very easily once you've analyzed it and you know what type of stresses you're getting in your members. So for now I'm just going to keep them all the same for simplicity. And then automatically the results are calculated. Now we just have to state what member we want to look at. So here is on the right hand side standard numbering system, so member 0, 1, 2, 3. So let's look at member 1 right here. Come down here, we can see the axial load along the length at 10 points. And we see the shear diagram and the moment diagram, and marked clearly with maximum and minimums, and all those values reported down here. And then we can also find out the result forces along any point of any member. So let's say we want to know what it is at 1 foot in. We get that those results here. Now we have the reaction forces. You notice that there's no units in these because MathCAD won't allow for mixing different units in a vector, and so because we have kip feet in one because it was a fixed connection and we have kips in the other, we left it unitless so that way you can use the values as needed. But here we tell you what the units are, what node it's at, and in what direction it's acting. And lastly we have the nodal deflection. Here we've got a slider bar that you can move, so you can magnify the deflection to see how the structure is deflecting and get a feel for how it's working. And lastly, we have the nodal displacements, the actual nodal displacements that can be used in your design. That's the brief overview of this program. I hope it helps, and thank you for watching.